right, so STEAM and video game development. This is presented by Tim Snyder and Wes Erlichman from the St. Louis Game Development. You will have access to their website as well as email address to reach out to them later, as well as their slides. My name is Kelly Remijan. I am Director at Large for the Illinois Council of Teachers of Mathematics, as well as Director of STEM Initiatives for the Regional Office of Education, number 40 in Illinois, just across the river from St. Louis. So I'm going to do a little background before they get into their presentation that talks a little bit about the math and how I have brought math and video game development together in a math classroom. So one of the things that I actually have done with preschoolers, we worked with shapes with students designing figures with these magnetized squares, and I gave them a design and then they had to match it with these magnetic squares. So these are some examples of scenery and characters that can be found in video games that are representative of pixels or squares of different colors. I've done that activity also slightly variated with middle school, high school, and then also in high school or algebra classes, I brought in the idea of Pac-Man, talking about graphing and about transformations of how we're moving Miss Pac-Man. So this is actually a video game on a coordinate plane. And again, you'll have access to all of these resources. And you could say where the Miss Pac-Man started, you could say where she finished, or how did she move to get to the first dot that she gobbled up. So again, Miss Pac-Man's a great old-time connection with math and video games. Another one that I've done a little bit with is I wrote an article on scratching the surface of Pong that brings old school Pong as well as algebra together. And so this is just a really short video to show a little bit about that.
In this case, I simply took off the paddle for the game just so it was out of the picture. And you can see that the ball travels in a linear manner.
Another thing with Pong is when that ball bounces off the wall, the bounce in which it hits the wall, the direction or the line it comes and hits the wall and then takes off at, that actually is angle of reflection. So that's a little bit of more with geometry. You can get into trig if you want, but Pong is a great kind of a old school game. And there's more that you could do with Scratch, Scratch where you can write programs that can model
the pencil
that will write
to show
the equation of
a
a
movement
line
when the flag is clicked. So we're going to click this flag. And you'll notice that the pencil is drawing a line.
So again, this is just, again, a good connection with Pong and with algebra, if you're talking about writing the equation of a line. Old school Super Mario. And you can see with Mario, he bounces, when he jumps, that's creating a parabola. So great connection, some great resources out there with parabolas. This is one, if you've never used Desmos, there are actually built-in lessons that you can use. And this gives you Mario, and you can then write the equation that will model the jump. And then you can actually test it and see if the equation that you wrote actually will match the jump within this video game. And so here's a quadratic, and it does match, in fact, the jump that Mario makes. So those are just some really basic, real quick kind of intros of things that I have done personally in the classroom, mainly at the middle school, high school level, but you can also make connections in early elementary as well. So at this time, I'm going to introduce again Tim Snyder and Wes Erlichman for St. Louis Game Development.
So our presentation is called STEAM and Video Game Development from STEAM to STEAM. Before we get started, I know Kelly said you could leave your screens off or your cameras off. That is okay if you want. But I watched my son during the pandemic, and I know his teachers hated it when he had his camera off. So if you're able to, if you're not in your car or whatever, and you could turn it on, I would love it. If not, that's also okay. I also understand that that you might be multitasking, and I don't want you to out yourself. Totally cool. Anyways, if you don't get the name STEAM to STEAM, STEAM is actually the largest PC game marketplace. And hopefully what our presentation will do is kind of show you how your students can go from their STEM education into, or STEAM education into actually releasing their own games on Steam. And it's probably a shorter pathway than you might think. But first, I can introduce me and Tim. Well, I'll introduce myself and have Tim introduce himself. I am actually, I've been at Worldwide Technology for about 21 years, doing right now I'm managing a mobile team. I did take a break in about the middle to work at Riot Games on a game called League of Legends. I also have published a game called Grave Sweeper on iOS and Android, and it's also on other platforms too. And then I also have some community stuff. And then I have two kids. I have a daughter who's a junior in high school and a son who's an eighth grader. And they were in the Parkway South District. So I don't know if anyone's from Parkway, but if you are, thanks for teaching my kids. Now Tim can introduce himself.
Yeah, I came to game development as an artist, and I got involved with the community around 2010 and have been making small games. And I haven't actually published a game, but lots of small prototypes and doing stuff for fun, working with others, making stuff. And I've been a part of leadership also a bit. Go ahead.
So yeah, so now I put this slide in. I think that when I grew up, all of the older people in my life all thought the games were all violent and they were bad for people to spend time with. I think people have generally moved beyond that, but I think there's some stuff to talk about here. Number one, like these are some of the biggest games on even like a gamer-centric platform like Steam. The first one listed here is Getting Over It. It's really just about climbing a mountain with a giant hammer. And it was a huge game. I don't know if you've heard of Stardew Valley. That's the middle one. It's just about starting a farm in a small town. And then the one on the right, I love. It's a game called Balatro. It's a game that looks and plays like poker, but it's no gambling at all. And these games are all huge. There's no violence, and it's all great. So, has anyone with their camera on, have you played a game in the last week? All right. Yep. So yeah, games are now everywhere. Everyone does it, even if it's just on their phone. But I want to dig into that violence thing a little bit more because as a game developer, you learn really, really quick that even if you have a game that's about violence, it's not really about violence. Games that look violent a lot of the times are actually about competition, exploration, community, a sense of accomplishment, or one of any of another dozen core experiences. The violence is the wrapper sometimes, but what keeps people playing is the experience underneath. Since then, if you've watched TV or movies lately, everything is crazy violent, way more than it was when I was a kid. And it feels like we don't give games the same like trust that we give. Like kids can watch Marvel movies without any parental like wondering what they'll learn. But most games don't kind of go the same way. I do think there are boundaries that kids need to have so they don't spend too much time and don't and know how to interact with strangers. But in general, I think games are a better form these days. But yeah, game devs are not always thinking about explosion, or aren't just thinking about bigger explosions. They're thinking about how to keep players engaged and caring about what they're building. And that's the conversation to have with your kids, not what can you put here, but what do you want your player to think? So yeah, so if games aren't what you thought, what are they? Every game is a Steam project. That's why we're here. So when kids when people are making games, they don't experience Steam as 5 separate subjects. They experience them as, I need to figure out how to do these things to make my game work. And that integration mirrors how these disciplines work in real careers too. Nobody at a game studio says, I'm doing math now. They're saying, how fast should this character fall to feel right? It is math and it is physics to do those things, but you're not thinking about math and physics. But Steam it intrinsically ties all those things together. Game development doesn't teach those STEAM subjects one at a time. It teaches them all at once, the way that they work in the real world. So rather than walk through each letter on their own, we're going to do the opposite. We're going to build a game. Tim's going to do that in a minute. And we're going to watch Steam show up on its own, and then we'll kind of call it out and tie it all together. Before we get started, where do games come from? So games come from, wouldn't it be fun to? So every game starts with, wouldn't it be fun to? So wouldn't it be fun to swing like Spider-Man? Wouldn't it be fun to solve puzzles by creating portals? That's where games start. It's like, what could it be fun? And you're already ahead of this. Your kids have game ideas. The motivation for them to learn STEAM is free. Your job as an educator is to get them to give them the tools to turn those ideas into something real. So can anyone that's on the chat, maybe mention a game that your student loves and maybe something they had to figure out in order to play it? We'll give it like a second and see if anybody has anything in chat. And I can't see the chat, so you'll have to let me know.
Minecraft is one that came up.
Yeah. Yep.
So a couple people said Minecraft.
Yep. I think Minecraft's another example of one of those like non-violent games that it has violence in it, but you don't see that. It's all you see is the creativity. So, all right, cool. So yeah, to figure out how to play Minecraft, they had to figure out how to be creative, how these systems fit together. They're learning when they play that. And so yeah, now we're going to see how they're built. Tim, do you want to take over and kind of show how he's going to show how using real world tools that game developers really use, like how to make a game.
Yeah. So Kelly mentioned Scratch earlier, and that has visual coding where you can drag and drop code blocks to make things work. And so one game engine that I use is called Game Maker, and this is a game engine that is used by professionals. What Wes mentioned it a couple slides ago. There's been several games made with it that have done very well, been successful. And I'm just going to walk through just a quick like little platformer thing here. When you load up Game Maker, you'll see something like this, and I'm going to just start a new game and do a pixel game because I'm going to use some sprites that are real small. And I'm just going to call it Steam Game. But this engine allows that drag and drop code blocks, and you can also code with it as you would in most other things with actual text. And let me just hide that. There we go. Okay, so when you load up the engine or a new game, you have a workspace and everything's blank because we don't have anything here yet. Game Maker works with objects. Pretty much anything you have in the game is going to be an object. So what we might do first is create an object for a player. And you can right click on the workspace and just do that. Or we can also go up here on the asset browser and select object and create. And sorry if my fan is noisy. And so creates a new object, and you can rename this. And generally, a good thing to do is to do something like O_player. And the reason for this is we're also going to create a sprite for it. And a sprite is just an image. And you can see I click this button here to make a new one. And I've already made a sprite, so I'm just going to import one, but you can actually edit the image and make something here. If you want, there's different colors you can choose. But I'm just going to pick this little sunglass guy here. And I'm going to name the sprite SP player. And so that way, using these little prefixes helps us to tell apart the object from the sprite over here in the asset browser. Okay, so with an object, there are events that you can add. And so I can just hit add event. And what I want to do is add a step event. And I'm going to select visual. And basically what a step is the game is running at 60 frames per second. So every 60 times per second, this step event is going to happen. And we could also, there's no one way to do this. So there's also a key down. We could do a key down right and add some code blocks in here, but I'm just going to do the step event because there's also a movement code block. Sorry, keyboard. There is a key down code block. So I can just put that in the step event, and here I can select right for the right key. And I just want to give my player object a horizontal speed. And notice you can do horizontal or vertical or the direction and set that to 3. And so GameMaker also has a room. Over here, you can select that. And I'm going to change the size of this to 480 to 320. And you can see it's pretty small. And all I need to do is add my player object into here. And I'm going to change my grid. Player. And then I can hit F5 to run the game. And right now we don't have much here. So it should just show the guy. And if I hit the right key, it moves. But it doesn't stop. So what I'm going to do is create a left and set speed to horizontal -3. And the reason for that, if we look at the room, the upper right corner of the game, the screen is 0, 0. So if I move him over here, you'll see at the bottom, it says 0, 0. There's some numbers of the coordinates where things are at. So anything, the X and Y grid goes from 0, 0 on the upper right corner and goes positive to the right and down. So going up and to the left would be negative. So that is why for moving left, we're going to make that a -3. So now, if we run the game, and I'm just hitting F5, it's a shortcut key.
When you're playing the game, I'm not sure it's actually showing up for people. Are you sharing your whole screen or just the window of GameMaker?
Okay. Yeah, I need to share the screen, and not just the window. Can you see it now?
Yep, yep.
Okay. It is pretty small. I will change that in a minute. But if I hit right, it starts moving and just keeps going. And if I hit left, same thing. So now we have movement, but it doesn't stop. So what we could do, like I said, there's no wrong or right way to do this. There's many ways you could do this, but what I'm going to do is add an else. So if we're not hitting the right key, basically it will set the horizontal speed to 0. And that should take care of it moving completely by itself. Yeah. Okay. So now we have some horizontal movement. And what we can do is make another object for the platform. And I'm just going to call that O ground. And make a sprite. Resize that to 16 by 16 like mine. There. And I'm just going to fill this with some red. Don't need to do anything fancy. I'm going to call that SP ground. So now in the asset browser over on the right side, you can see I've got a ground and player object, and I've got ground and player sprite. And we're not going to do much with the ground. It's going to be, most of the code will be in the player here. But we can go back to our room and just drag ground object in here. And then you can actually resize things. So it's real easy to make platform load the player. Obviously, it's not going to move down unless we do something about it. So we could do gravity. Gravity exists in GameMaker. And we could just run that and see what happens. Okay, well, it goes right through the platform. So there's not any collision with the platform by default. We have to make that happen. I'm gonna save this and just to speed things up.
Tim, while you're doing that, question
Yeah.
was, first of all, is this a free program, GameMaker?
I'm sorry, I didn't hear it.
Is this a free program, GameMaker?
Yeah, I
Okay,
just opened this and made it from. I did not make GameMaker. This is sorry, it's a game engine and it is available for free as a free tier. So anyone can get it and download it, use it for free. They have other tiers that are paid also.
gotcha. And is something like this, the question was asked, is this something that can be on Chromebooks?
I kind of answered that, and I don't know if Tim knows that, but I answered it in the chat. It can technically be on Chromebooks, but it's probably too complicated to get it onto Chromebooks generally. Chromebooks are running Linux at some layer, so you'd have to like do some weird stuff. So most likely it's going to be for Windows and Mac and Linux, for all practical purposes.
Yeah. But I think I picked the wrong one here. I'm just going to jump to a project where I figured out the gravity and everything here. But instead of using gravity, what I did is created a few variables. And so there's also a create step that you can add, which runs when the game starts or whenever the object is created. In this case, it's just when the game starts. And I made a few variables: move speed, jump speed, and grab for gravity. GameMaker has a built-in gravity, and that's what I was using before, and that's why I had to rename it. I couldn't name it gravity because they already have a variable called it. But I've given some values to those. And then in the step event, I've changed it just a bit where instead of I'm putting in a number, I have that variable for move speed. So that if I wanted to make the player move faster or slower, I could just change that here. And it will go into the left and right code. Same for gravity. What I've done is instead of just putting gravity, I'm using a vertical speed. And basically what this is doing is I'm checking for the ground below the player. And if that's there, it moves up to the player or up to the ground. That's what this move glide does. And then it sets the vertical speed to 0 so that it stops moving. And then also if the player is on the ground, you can press up to jump. And I just give that a vertical speed of the jump speed. And you'll notice the jump speed is a negative number because we're going up. And then if the player is not touching the ground, else it's applying gravity. And so if the vertical speed is less than gravity minus 1, we're going to add 1. And that's what this relative box does. It keeps adding that value every step instead of just setting it to a constant. So I'll just run this real quick to show that got this guy here, and he can jump now and move around. And I also have another one there that is using the code and not the visual script. And I'll show that real quick. But they both do the same. And I have, again, like the room is set up so I can move these things around. So you can build levels and base it on your jump. And if I wanted to, I could adjust the jump speed. Let's make this 20, and then maybe make the gravity 5. And you can iterate on things very easily and see how it affects things. And obviously I got a little bit of a bug. I need to figure out a way to keep the player from getting stuck into the platforms. But you can see how just changing the values can really change the game, and you may, you would probably want to alter your level before you get it. And then just real quick, I will show you the other player here, where it's basically the same, but I've done it with code instead. So I've got the create, and instead of having those code blocks that I drag from the side, I'm just typing code. And it's similar, where I just have a variable and set it to a value. And then the step event, I'm basically doing the same thing. I'm checking for a key. So in this one, I've set D to right and A to left. And that gives me a result of 0 or 1. And then I'm doing the movement a little different, where I set the horizontal speed to the move speed times right or left. So if the player or someone is pressing right and it subtracts the left, it will work out so that if they're pressing right, it'll be 1. If they're pressing left, it'll be -1. Okay.
So Tim, you had a question. What is the name of the language that you're using here?
So GameMaker has its own scripting language. It's called GML, GameMaker language. It's similar to JavaScript, if you've heard of that. It's a bit different, but they still have their own like functions and things like this place meeting. And the visual scripting really has anything you can do. Well, maybe not anything, but most of the things you can do with code, the visual scripting has. So that place meeting is pretty much the same as this if object at place. So I'm basically doing the same thing, but just it's a bit quicker to be typing everything if you know what you're doing. So just wanted to show you that, and I think that's about it. We can go back back to Wes.
So,
I have to stop sharing it.
yeah. So, yeah. Tim, I think there's some echo that was coming through. If you can mute, I think it'll fix it, maybe. Maybe not. I don't know. Okay, that's working for me. Um, okay, so you saw what Tim showed off. What he showed off is generally what people are really using to make games like in the real world. And I don't know how many people here have used Scratch in your classes, but you could see maybe that the gap between Scratch and between what Tim showed is not really that different. Like he's doing kind of the same things. It's just maybe like has a higher ceiling. So, and we'll get more into that in a little bit, but the main point I wanted to talk about is that all of these things are kind of already in your curriculum. So Tim said the word gravity, he said collision. Those are just Newton's laws. Every platformer runs on real physics. One of the questions I was going to ask him is if when he pushed right, he was moving it by 3 pixels. You were using essentially moving it by 3 pixels and not velocity. Is that right, Tim?
Yes, I think so. The horizontal speed, I think, works the same as if you're just moving the sprite from the object a few pixels at a time.
Yeah, and I think like that's one of those things that you learn as a game developer really quickly is like, okay, I've got this guy moving. This is great. Now I want to be able to have him run faster like Mario does when you push right. And so you have to like investigate what that means and actually learn what velocity does and how really making your character move more realistic ties directly into those physics terms and real things. So at like students will learn these things over time as they just want to make their games better because there's no other choice. Like that's just how you make games feel more real. And that's really what people are going to want to do. That's the S for science. The T, a real dev environment. So technology, Godot, Game Maker, whatever tool you're using, version control. Tim, you didn't know Git at all before you got started, and then you learned it. As people get more into making games, they have to learn these professional tools that people use when they make any software. So the technology part comes for free. E, engineering, level design, and iteration. You saw Tim iterated on the different like jump levels and learn things. Like, oh, I need to figure out how to not have him bang his head or like have something different happen. Those are things that you're going to learn just by playing, and that's iteration. That's like engineering. That's trial and error. That's really what it all is. The art is obvious. Like he dragged in some smiley faces, but Tim is capable of like amazing art, and he's very good and very quick. We just want to show something quick. And then the M for math, again, probably the most obvious one. Coordinate planes, jump parabolas, loot drop rates. That's one thing that you learn really quick as a game designer when you start playing your own game, is that it breaks really quick when you have the wrong number for the amount of like health or like amount of gold to get or like so you have to learn about how probability affects the economy. You have no choice because that's just part of making the game fun. Um, so the other part of math is like the probably the most important thing you can teach about math through games is kids will always ask, where will I ever use this? And in game development, it answers that question pretty much every 5 minutes. You're always using math. You're always learning how to do new things. Um, so did you notice anything in the demo that ties this to Steam that I didn't say yet? You can put it in the chat, or what do you guys think? I don't know if anyone's saying anything because I can't see the chat.
I will say while people are maybe thinking about that is a question that was, and again, you may not know this, but they were asking, are there other things that people can use that are very similar to Game Maker that might be able to be used on Chromebooks? And that's what I know a lot of schools, at least
Yep.
probably elementary, middle school use Chromebooks and high school, but I find that probably pretty much every elementary, middle are using Chromebooks.
Yeah, that's a good question. I the ones that we've kind of focused on are not really web-based. Um, so I will have to get back to you on that, but generally a lot of the tools are just going to use mainly Windows, and then but now they're available for other platforms like Mac and other things. But um, the games that these will make will run on Chromebooks because they just generally everything can output to web. But but yeah, I most things would not be able to work on Chromebooks. That at least not without a lot of hoops. So
And then
um,
I was also
Here's
going to add, and I
scratch.
won't put it in the chat box, but I think also like storytelling. I mean, you got to figure out what your story is. That's kind of your writing, your English
yep,
part that maybe isn't addressed here, but really I think is crucial to what is the story behind the game that makes it exciting.
that's
There,
true.
there
And I
are
would add,
some there are some tools that are web-based, like Twine and Bitsy, that are very simple and they're more narrative focused. So those would be probably good ones for if you want to go with something more narrative. Go ahead,
yeah,
Wes.
that's true. Twine and Bitsy are both really good, and they can make different games. They're not going to teach you a lot of like programming concepts because they're more about the game design and storytelling. But yeah, the other thing I would add for the arts is I think theme. I think it's kind of like probably under communicated, but a lot of games have deeper themes um, that are kind of under the surface. And like building a game based on the theme, which we do in game jams all the time, I think is a way um, of kind of starting from an idea and like moving that into all of the other areas of stuff STEM. So yeah. So anyways, yeah, your students won't say I'm doing STEAM if they're working on a game. They're just going to say I'm trying to make it feel right. And that's what you want. You want them to learn stuff without realizing they're learning it. And that's also how they're going to kind of learn stuff um, without uh, like they'll learn that the tools that they've learned in math are actually coming into play in real life without being told that. So so yeah, I'm going to jump into some other topics that I like to talk about because I think they're interesting to think about that are also tied to game development in some way. First is gamification. Gamification, a lot of how it's been sold to educators is like just putting a reward system around the things that kids would already learn. I think personally that that's kind of like kind of a little bit manipulative and it's a little bit underwhelming. Like it might work toward getting kids to like to learn things, but really what they're learning is uh that you can like rewards will get me to do stuff. And I don't think that's a great thing to teach kids. I think it's better to tie systems into the lessons that you want people to learn. Some examples of games that do this well are SimCity, teaches urban planning, obviously. I don't know if you've heard of Kerbal Space Program, but Kerbal Space Program teaches orbital dynamics and Newtonian physics and staging. You need to learn it because if you don't learn those things, your rocket will explode. Uh, it's really a game about rocket science, and people play it a lot and love it because and don't realize that they're learning because they're not playing it to learn; they're playing it to have their rocket not explode, and they learn all these other things through that process. Factorio is about supply chain logistics. People don't think about that, but that's really what the people are doing. Civilization, you learn about resource allocation and geopolitical trade-offs. I don't know if anyone's played that before, but like, do I break this treaty? Is a question I never thought I would have to think of before and never would have had to think of had I not played Civilization before. That's a really interesting. And then Plague Inc. teaches you um, about disease transmission. Uh, and then Papers, Please is we talked about Theme earlier. That's a game where you have to make immigration policy decisions given limited information, and you see the outcomes of those decisions. So it really gets people to think about things ethically that they probably like would never have been confronted with. Um, I think yeah. So in my mind, the best gamification is where the lessons are tied to the mechanics, and mastering those mechanics are really mastering those like STEM concepts. So, um, so yeah, that's just another layer. The other thing I want to talk about, the thing I want to talk about next is something that we're all going to confront over the next couple of years, and you have been confronting over the past couple of years. It's AI. AI when it comes to game development um, has is sorry um, is something that is pervasive now in software development and in other areas. How many? I don't know if the hands up reaction, but if you use ChatGPT or Gemini, can you do a thumbs up reaction? All right, we got a couple here. Got one on the camera. I love that. What about has a student used AI on something that you've assigned? Thumbs up. Not too many. I don't know if there's a couple. I bet they are, and you don't know. And then finally, if you're sure that they haven't used it, give me a thumbs up. I'm not seeing a lot of reactions. Okay. Yeah, because kids are using AI now. You can't keep it away from them just because that's where life is. But you can so yeah, it's being used for code assistance. As a software developer, we've been encouraged to use it as much as possible. It is kind of insane. Art generation is something that you can do if drawing is a problem in order to get some quick assets made. Sound and music, again, rather than spend a lot of time on that, you can do that. And then the one that I think is really going to be transformative toward the game industry is faster prototyping. If you have an idea and it takes like 10 minutes to half an hour to run to an AI and try it out, you can find out really, really quick if it's going to work or not. Um, I think that as I think that as people can try things out and the weight of trying things out is not as high, we're going to see a way more creative games in the future. And just because the cost of experimentation is a lot lower than it has been in the past. So uh, the and next I want to talk about the obvious concerns. I think that if you're encouraging kids to use AI, you can't just say use AI to build a game. You have to really try to frame it in the way of education. It's like build a game that demonstrates projectile motion, and then explain how your code works, and then show me how you change what the AI suggest from what the AI suggested. AI never gets things right the first time. You're continuing to iterate on it, and as you iterate, you learn. And I think you learn those concepts when you see what they changed. So what you really need to do is have students look at what changed so they can try to understand. That's what I do as a software developer every day. Is like after something is coded, I need to know how it works because I have to maintain it. So I am constantly learning things from AI that I'm then iterating on it with and talking back and forth, and then working with my team so we all understand how it works. Um, Art and ethics. We talked about ethics of using art. I think that I'm hoping that there are a lot of personally that we figure out legally where that stuff lands, where people are getting paid for what's being used. I think that art. I think that the genie's out of the bottle, and art is going to be made using AI in the future. And I just think that we need to figure out a way to be fair and ethical about that. And my son is actually writing a paper on AI and ethics, and this is one of his main points uh, for that he's putting in there. Another thing that I think a lot of anti-AI people focus on is the homogenization, because it's all trained on data. If people stop having ideas, it's all going to start to feel the same. I'm already seeing that in like the apps that AI builds. And I think like the secret weapon for companies going forward is going to be having great creative people in like art approval roles where they can just make sure that we're not doing anything stupid or like that's too generic. So skills are going to continue to matter. People are going to have to continue to like fix things when they break. So AI is not going to solve all of our problems. That's the abstract. I do want to talk about a little bit because this came up while I was writing this presentation, and I thought it was kind of crazy. Talked about how my son is an AI skeptic, and he's writing that article. He always is. He's always saying that's AI art. Like we'll be at the restaurant, and on the wall there's like a picture, and he's like, "That's AI art." And I'm like, "Why would they put AI art on the wall?" But he's just like, he thinks everything's AI art just because that's what kids think these days. And maybe it is, maybe it isn't. So he doesn't like it, but he got over that hump and made a game during class, not because he loves AI, but because he wanted to play a game in class, and his Chromebook let him make a game without having to without having to like install a bunch of stuff, which you guys have already kind of touched on, but also without having to like get permission from a teacher. So he was just like in the middle, I would assume French class during downtime between assignments, and he was like, I want to make this game. So he talked to the AI and ended up working through it and making a first person exploration game where you try to get to the end of a level, and it's a maze, and you have like two tranquilizer darts apparently, and as you get through levels you'll like unlock money that you can use to like buy more inventory, and these are all things that he figured out on his own how to do, and it's just in this one chat with Gemini. The point of this is that your kids are already making games, and your kids are already using this to learn STEM concepts without realizing it. I think that your job as an educator is going to be to take those things that they're doing in their like already doing, already like kind of like doing behind the scenes, move those to the surface and help guide them toward making those connections and help guide them toward like the people that maybe wouldn't do this, kind of show them the possibility, get them to think about how they're capable of using AI and like of bringing their ideas to life like in a way that they couldn't have before, and essentially help guide them toward using it to learn instead of using it to goof around, right? So students are already doing this stuff, and the question is, what tools will they need to do it well? He's never going to be able to ship this game because it's trapped on Chrome. I guess you could put it on a web page, but if he wants to like bring it to life and make a real game out of it, you will need to use one of the tools that real game developers use. I know that Chromebooks is going to be a constraint, and I know that we've talked about Scratch being a good solution. I think Scratch is great for like fourth grade and below. It's okay to like to do the best that you can, but I think that like if you saw the difference between Scratch and what Tim did, they are very close. I think that if you can give kids the tools that they have a higher ceiling, where like they can make a game using Scratch that's similar to what they could make in Scratch, or they could take it all the way to a game that they publish on Steam. I think equipping them with those tools will get them a lot more passionate about it and a lot more excited, because they're not going to feel that like that barrier of like, I'm doing this thing and now I'm not going to be able to take it any further, or it's not going to translate directly into something that I can release. So yeah, these are all of these engines have a free tour, free tier, all are free for students. Game makers, what Tim showed off, Undertale, you've heard of your kids say Undertale before. That was made in Game Maker. A local game called Crashlands was made in Game Maker, and it started a company that now is continuing to grow, and they've made a lot of money. And then, but they have drag and drop, they have that Scratch code, and then they have, as Tim showed you, Game Maker markup. So it's got a lot of layers. Godot is free forever. It's open source. It's by MIT. And games made in Game Maker are Brotato, Dome Keeper, Cruelty Squad, and I think a lot more games are going to be made in Godot going forward. For the indie community, it's kind of like taken over from Unity as the go-to engine because they don't have to pay Unity money when they make their games. And it feels really similar to Unity. They kind of have the same like workflow. Unity is probably the biggest indie game engine that's used, and it again has visual language. A lot of it's visual. You can see what's happening. You can change some of those variables right in line. And the games made in Unity include Hollow Knight, City Skylines. Really, probably a lot of games on your phone have been made in Unity, because like most of the games I play have been on my phone. And yeah, so and teaching kids that is just as easy as kind of what Tim showed. My suggestion on how to learn it and how to teach it would be to look up videos on YouTube. Tutorials are going to be the best thing, and a couple simple YouTube tutorials that teach you the basics, and then you can go from that to just having people learn. Yeah, the tool. I think the tool should have a higher ceiling. That said, if you go another direction, is what Tim talked about, using something like Twine, which is kind of like choose your own adventure engine. That's incredibly simple to use. We've done game jams where people make games in an hour using Twine, and then we share them together in the next hour. And so in 2 hours, people have made a game and already shown it off to all their friends. So it's a very, very simple to use tool. And then, yeah, I also want to mention itch.io. Once people make games, Steam isn't the only platform. You can post any game on itch.io. And then a lot of games are made in game jams, which is a set period of time. People start a game at the beginning based on a theme, finish it at the end of that time. If they don't finish it, just show off what they've got. But a lot of the game jams are run through itch.io, and all the games are published, and you can see them and play them and download them. And it's just an easy way for people to share games. And then next, this is kind of a complicated slide. So can kids or can people do this for a living? I mean, obviously people can do it for a living because games like Fortnite exist and like everything on your phone. It's a very hard very hard job market to break into. There's a lot of people that want to make games, and there's not as many jobs as to meet that demand. And because of that, a lot of people in games end up being taken advantage of. There's a big call for unionization that is successful in some areas and not in others. But the reality is that most game developers only have about 5 to 7 years in game development before they move on to another career. That said, people who do that, really, I don't think regret it. I think they've learned a lot, and they haven't been stuck without something that didn't transfer over to another job. Like skills compound, like all the things we showed, Unity, C#, Git, all those iteration, all the like thinking through how code translates into what you experience as a user. All of those things are things that transition into any job in tech. To put it in a real world environment, we hired someone at work last week that came from a game development. She graduated with a game designer degree from an art school. She went on from that to become to work for a educational game company, and then went on to work at a like training company, and now she's just moving over to work on like a web app as a front end developer. So like she didn't have a gap because she's got it starting games. Also, 2 out of 4 people on my team have worked in games before, not including me. One of the guys worked at a place called Black Lantern, where he made Deal or No Deal on the Wii and Duck Dynasty on Nintendo 3DS. So like he's made real games, and then he's moved over into software development. Another guy on my team was a tester at PopCap who worked on games like Plants vs. Zombies and Peggle. So these are not people that didn't have a job, that don't have a job now. They're people that work in tech still, and they probably wouldn't be here if the GIF games didn't get them excited about it and make them want to do the job. So it's different than my daughter, who wants to be a shoot, I don't want her to hear me, but she wants to go into like social work, which is not bad. But I think like they have set themselves up for a great career, despite wanting to get into games, and maybe because of trying to get into games. That's also how I feel personally. And so yeah, we're running out of time, but what you could do to get your kids involved, do like basically surface what my kid did. Bring up Gemini and see, hey, come up with an idea and see if it can make a game. What can we learn from this? What concepts from class do you think apply here? Any of those things will get your kids more engaged than probably what you're going to do otherwise. You could run a mini game jam if you have time. We talked about Twine. That's a really cool way to bring technology and storytelling together and turn it into something real. The game at the bottom here, Speedrun Squad. We run a global game jam in St. Louis. That's one of the biggest in America and one of the biggest in the world. There's a middle schooler who came to one of those early events. He made this game called Speedrun Squad at one of the events, kept polishing it. It's available on Steam right now. It was on iOS for a little while. His mom, every time she came back to the event, she would thank me personally for like getting her kid interested in games and just like making him excited about something, because he wasn't really before, and him like just getting into games and then creating something and actually putting it, like getting it, publishing it himself, I think gave him like a sense of identity that he just didn't have before. There's countless stories like that, but I really wanted to call that one out. And I think we're running out of time, so I'm going to real quick go to the last slide. So games are how the next generation is going to learn to build things. Your students have ideas, they already care. Meet them where they are, tie them to what you're teaching. And yeah, and if you have any questions, how to contact us is at the bottom of the slide. The slides will be sent out in a couple weeks. And I think I'm going to pass back to Kelly to wrap up if we have any time left.
Paul, I would like to thank Wes and Tim for presenting today. It gives us a different perspective from the creative artistic side, where Tim comes from. Wes, again, his worldwide technology, working in software development, but then took a break and worked for Riot Games. So it allowed him to have a different perspective. And I think having a different perspective for teachers is important, and hearing from people in different professions that we can then talk about with our students is going to help them. We're going to help meet them at what they need, what they're interested in, to bring in connections to whatever it is that we're teaching. So again, I want to thank them very much for presenting today. Again, I want to thank everyone on behalf of the ICTM and the ROE40. I want to thank everyone for attending. Thank you so much.